Dear students, so in this video, we are going to start with numericals on thermal or steam power plant. So we will see 3 to 4 examples or numericals based on this steam power plant. Mm. This numerical were asked in exam for 4 to 5 marks in this introduction to energy sources and its conversion unit. So we have a basic unit conversion is there that is given in this first slide. So we have first unit, that is energy. The SI units of energy is joule, and the power is there. The unit of power is watt. So these are the SI units. Now unit conversion will be there. So first unit conversion, 1 watt is equals to 1 joule per second. 1055 joules, it is nothing but the one British thermal unit, BTU. 1 HP is 745.7 watt. So it will taken as 746. Next one is 1 kilowatt is equals to 1000 watt, or we can say 10 raised to 3 watt. 1 megawatt is 10 raised to 6 watt. 1 calorie is equals to 4.184 joule. So these are some unit conversions that are necessary in this problem or example of thermal power plant. Now we will see the first example. The example is a steam power plant has coal consumption of 165 tons per hour. The calorific value of coal is 3500 kilocalorie per kg. If the power generation is 250 megawatt, find overall efficiency of plant. Use relation 1 kilocalorie is equals to 4.18 kg. To solve this, we have converted this problem into a given data, and what is the given in the problem? That is nothing but the given data. So we have coal consumption. So coal consumption is denoted by a symbol M. So M is equals to coal consumption. Now this coal consumption is given in 165 tons per hour. So we have to convert this 165 tons into kg. So 1 ton is nothing but the 1000 kg. So it becomes 165 into 1000. Per hour is there. So we have to convert hour into minute and minute into second. So hour into minute is 60. Hour into minute into second is again 60. So this 165 tons per hours, it becomes kg per second. So we convert tons into kg, that is 165 into 1000, and hours into second, that is 60 minutes and 60 seconds. So after calculating, we get the mass consumption, M is equals to 45.83 kg per second. Now we require the coal consumption or mass, it is always in kg per second, or if it is volume, it should be meter cube per second. Then we have another value, that is CV. It is called as calorific value of the coal. Now it is given 3500 kilocalorie per kg. So it is 3500. Now conversion is given, that is 1 kilocalorie is 4.118 kg. So 3500 into 4.18. So we get calorific value 14,630 kilojoule per kg. Now this unit is always required. It is in kilojoule per kg. Now another, the power generation is given, that is 250 megawatt. So we have converted that 250 megawatt into kilowatt. So that is 250 into 10 raised to 3 kilowatt. Now we have to find out the overall efficiency of plant. So that is efficiency is denoted by the term eta. Now to find out efficiency, we have two terms. Now we know that efficiency is nothing but the output power upon input power. So we have to find out the output power, then we have to find out input power, and from that we can find out the efficiency of power plant. So first we will find out what is meant by input power. So input power, it is nothing but the what is input given to the steam power plant? It is the coal consumption and calorific value of the coal. So that is the input of the power plant. That is the fuel supply to steam power plant. Now fuel is coal. So it is nothing but the coal consumption into calorific value of the coal. So M into CV. So mass is given, that is 45.83 into CV is 14,630. So after calculation, we get 670.49 into 10 raised to 3 kg per second. Now this is in kg kg per second. This is in kilojoule per kg. So kg answer we get kilojoule per second. Now kilojoule per second, it is nothing but the kilowatt. So we get a value of input power as 670.49 into 10 raised to 3 kilowatt. So this is the input power. Now output power is given. So from that we can find out the efficiency. So the output power is, it is given 250 megawatt, that is 250 into 10 raised to 3 kilowatt. So overall efficiency of power plant. So overall efficiency is nothing but the output power upon input power to the plant. So we get efficiency is equals to eta is equals to 250 into 10 raised to 3 divided by 670.49 into 10 raised to 3. So we get the efficiency as 0.3728. So in percentage, we can say that the overall efficiency of this thermal power plant, it is 37.28%. So in this problem, the main concern is about the coal consumption. जो कोल कंजम्पशन का वैल्यू होना चाहिए वो ऑलवेज केजी पर सेकंड होना चाहिए. So we have to convert any value into this kg per second. This is very much important. Similarly, we have calorific value. वो भी calorific value आपका होना चाहिए किलो जूल पर केजी, इसमें होना चाहिए कंपल्सरी. So that multiplication becomes kilojoule per second. So mass into calorific value, that is in become kilowatt. So ये kg per second के लिए ये यूनिट कन्वर्जन करना होता है. ये हो गया फर्स्ट प्रॉब्लम. नाउ वी विल सी द सेकंड प्रॉब्लम. So the second problem is again same. A small generating plant, it has 100 kilowatt of capacity, uses a gas, it has a calorific value of 4000 kilojoule per meter cube, and the volume of gas required per hour when plant is running at full load condition, it is given 450 meter cube per hour. So we have to find out input power, overall efficiency of the plant, because output power is given 100 kilowatt capacity. So in this case, there is mass flow rate is not given, but volume is given. So say M is equals to volume of gas required per hour. So it is given 450 meter cube per hour. Now we have to convert. Now meter cube is there already. So we have to convert hour into seconds. So 450 divided by 60 into 60. So we get this volume of the gas as 0.125 meter cube per second. Now again calorific value, it is given in kilojoule per meter cube. So it is 4000, and the power generation is given 100 kilowatt. So output power PO is equals to 100. So we have to find out input power PI and efficiency, overall efficiency of the plant. So first we have to find out input power. Now input power is nothing but this volume into calorific value, because it is in meter cube per second and this is in kilojoule per meter cube. So we have to multiply this mass into CV. So volume of gas into calorific value of gas. So M into CV. So 0.125 into 5,000. So it is in meter cube per second. Mass or volume, it is in meter cube per second. This is in kilojoule per meter cube. So we get meter cube get cancel. So we remaining kilojoule per second. So that becomes 500 kilojoule per second, and that is nothing but the 500 kilowatt. So this power is there. That is the input power. Now output power, we have already known the value of output power, that is 100 kilowatt. So we have again formula, overall efficiency of power plant is equals to output power upon input power. It is 100 divided by 500. So it is 0.2. So the overall efficiency of this plant is 20%. So it is in percentage. That is the 20%. Now we have another problem, that is problem number 3. In this problem, we have to find out both input power as well as output power. So again, a steam power plant is there. In that, coal consumption is given 16,200 kg per hour, with calorific value is also given, that is 17,793.9 kilojoule per kg. Speed of steam turbine is given, that is 1000 rpm. Torque is given, this 477,464.8293 Newton meter. So we have to find out input power, output power, and efficiency. So coal consumption, it is 16,200 kg per hour, now converted into second. So 16,200 divided by 60 into 60. So hour into minute 60, minute into second, again 60. So we get the mass flow rate or coal consumption in case it is 4.5 kg per second. Now again, the calorific value of the coal, it is given as 17,793.9 kilojoule per kg. So it is given in this unit. Again, speed is given of the turbine, it is 1000 rpm, that is 1000 revolution per minute. And the generated torque is given, that is 477,464.8293 Newton meter. Now we convert this torque into kilonewton meter so that we get power is in kilowatt. So we have converted and we get torque as 477.464 kilonewton meter. So why we convert this Newton meter into kilonewton meter? So that we get power in kilowatt. So we have to find out first input power, second output power, and third one is efficiency. So we will find out first input power. So input power, again same, the formula is there, that is coal consumption into calorific value. So M into CV, 4.5 into 17,793.9. So we get the value, it is in kilojoule per second, that is nothing but the kilowatt. That is 80.072 into 10 raised to 3 kilojoule per second. That is nothing but the 80.072 into 10 raised to 3 kilowatt. Now here one formula is important when the torque and speed is given. So the power generation by steam power plant, the output power is nothing but the 2 pi n t upon 60, where n is the speed, t is the torque, and 60 is for, because this n is in rpm, so for conversion this rpm into rps we divide by 60. So 2 pi, speed is 1000, torque is 477.464 kilonewton divided by 60. So we get value is in kilonewton per second. So it is 49,1999.87. So in kilowatt, it becomes 49.99 into 10 raised to 3 kilowatt. So again, same formula, overall efficiency of the plant is output power upon input power. So output power is 49.99 into 10 raised to 3. Input power is 80.072 into 10 raised to 3. So after calculation, we get the efficiency as 0.6243. Therefore, in percentage, we can return that the overall efficiency of this plant is 62.43%. So we multiply this value into 100 to get the value is in percentage. So this is the third problem. Fourth problem will be there. In that, this problem is having a steam power plant has coal consumption that is 16,300 kg per hour with calorific value same as like last problem 17,793.9 kilojoule per kg. Speed of turbine is given that is 1,100. Here a radial distance and generated force is given. So torque is not given. So torque is nothing but the force into distance. That is the formula we have to use. So we have to find out this generated torque, input power, output power, and efficiency. So coal consumption 16,300 kg per hour. So we have to convert this kg per hour into kg per second. So divided by 60 into 60. So we get 4.5277. It is the coal consumption. Then calorific value, it is same 17,793.9. Speed of turbine is given 1,100 rpm. Generated force is given. It is in Newton, so I have converted it into kilonewton. So it is 3118.309. Why we have converted into kilonewton? Because we have to convert power requirement. It is in kilowatt. And R is radial distance, that is in 1.5 meter. It should be in meter. So generated torque is nothing but the generated force into radial distance. So generated force is 318.309 kilonewton into 1.5 meter is the radial distance. So we get 477.46 kilonewton meter. It is the generated torque. So we have find out generated torque. Now we have to find out same input power, output power, and efficiency. So next is input power. So input power is coal consumption into calorific value of coal. So M into CV 4.5277 into 17,793.9. So we get the input power as 80.565 kilowatt or kilojoule per second is nothing but the kilowatt. Similarly, output power, it is 2 pi nt upon 60, 2 pi 1100 into 477.464 upon 60. So it becomes 54.99 into 10 raised to 3 kilowatt. So again, same formula, overall efficiency is equals to output power upon input power. So 54.99 into 10 raised to 3 divided by 80.565 into 10 raised to 3, we get efficiency is equals to 0.6825. So if we convert it into a percentage, so we have to multiply by 100. So we get overall efficiency as 68.25%. Now there is a small, sometimes the question will be asked for coal consumption that is given in say 1,000 tons per day. Sometimes it is given 1,000 tons per day. Now for this per day, we have to convert it into kg per second. Now how we can convert this kg per second? So 1,000 tons, we have to convert it into kg. So it is nothing but the 1,000 into again tons to kg, it is again 1,000. So 1,000 into 1,000 divided by now day. In day we have 24 hours. So divided by 24, we get converted into tons per hour. Now hour to again minutes, we have multiplied by again 60, and minute to again second, we have multiplied by again 60. So after that, we get this value is in kg per second. This is very much important because in some of problem it is asked that the coal consumption it is in tons per day. So we have to convert that day into hours. So in a day there are 24 hours. Then hours into minute 60, minutes into second again 60, and tons into kg it is nothing but the value into 1000. So that is a key point in that numericals based on a steam power plant. So this numerical is asked in an exam, minimum for 4 marks, maximum up to 5 to 6 marks, based on what are the solution for that problem. So this is all about various numericals based on steam power plant. And keep remember that you have to subscribe my channel so that you get new videos in your YouTube profile. So this is all about uh, today's video. So similarly, I will stop the video. Thank you very much.